The sound arrives before anything else. Through the acrid smoke and coral dust of Betio Island, that terrible mechanical rhythm. Not the sharp crack of rifles, not the thunder of artillery, something worse. The relentless chatter of automatic weapons stitching death across Red Beach 2 with industrial precision. Corporal William Dean doesn't need to see the Japanese to know they're coming. The ground trembles, hundreds of boots pounding coral, desperate voices shouting "Banzai!" And threading through it all, that distinctive slow talk of Type 92 heavy machine guns, the sound American Marines have learned to call the Woodpecker. Dean checks his M1919 A4 Browning one final time. The air-cooled barrel gleams dully in the dawn light. 250 rounds of .30-06 Springfield ammunition snake through the feed mechanism, ready to transform potential energy into death at 600 rounds per minute. 45 pounds of American engineering sitting on its tripod, waiting. The Japanese charge crashes out of the smoke like a tsunami of flesh and steel. And in that moment, as Dean's thumbs press down on the trigger and his Browning erupts with a sound like fabric tearing, the Pacific War reveals its essential truth. This battle wasn't decided here. It was decided 3 years ago in Detroit, in Buffalo, in Rock Island, Illinois, in the humming factories of General Motors, where workers who used to build steering columns now built machine guns, where the philosophy of mass production, good enough weapons in overwhelming quantities, was about to prove its superiority over everything Japan could manufacture. The war wasn't won on beaches, it was won on assembly lines, and the weapon in Dean's hands represented the decisive edge that no amount of courage could overcome. Architected vivid narrative framework emphasizing industrial philosophy's decisive role. I need to introduce the M1919 through its creator and the philosophy behind it. Focus on practical design for mass production, reliability over perfection. To understand how America won the Pacific War, you have to understand a gun designer who died in 1926, 7 years before that war even started. John Moses Browning never saw Pearl Harbor, never witnessed Guadalcanal or Saipan, but his ghost haunted every Pacific battlefield, speaking through the weapon that bore his name. Browning's genius wasn't complexity, it was brutal simplicity. The M1919 emerged from his earlier M1917 water-cooled machine gun, the weapon that had performed so well in France that the army wanted more, but lighter, more mobile. Freed from the burden of water jackets and hoses that made the M1917 a semi-permanent fixture wherever it was emplaced. The solution arrived in 1919. Air cooling. Eliminate the water jacket, strengthen the barrel, let physics handle the cooling through airflow and thermal mass. The result weighed just 31 pounds. Add a 14-pound tripod and you had a complete weapon system at 45 pounds. 2 men could carry it, run with it, deploy it in seconds. But the real genius lay deeper. Browning designed for production. The M1919 used relatively loose tolerances, a deliberate choice that would save thousands of American lives. Engineers obsessed with precision might have called it crude. Battlefield Marines called it perfection, because when sand jammed the works, when coral dust infiltrated the mechanism, when tropical humidity corroded every metal surface, those loose tolerances meant the gun kept firing. Think about what that means. Tolerances aren't just measurements, they're philosophy. Tight tolerances mean precision, perfect fit, maximum theoretical accuracy. They also mean that when one part expands from heat or contracts from cold or gets fouled with debris, the entire mechanism seizes. You have a 31-pound paperweight. Loose tolerances mean forgiveness, room for error, space for the imperfect conditions of combat. A gun that works at 95% efficiency 100% of the time beats a gun that works at 100% efficiency 50% of the time. The M1919 fired the .30-06 Springfield cartridge, itself a masterpiece of standardization.
Adopted in 1906, this round had proven itself through decades of use. A 150-grain bullet leaving the barrel at 2,800 feet per second, lethal at 1,500 yards, powerful enough to punch through cover, light enough to carry in quantity, and most importantly, produced by the millions in completely standardized form. Every round from every manufacturer would function in every M1919 ever built. The gun's operating system embodied elegance. Recoil operation. Fire a round and the barrel and bolt recoil together briefly. The bolt unlocks. The barrel stops. The bolt continues rearward, extracting the spent case and cocking the firing mechanism. A spring drives it forward, chambering a new round. The barrel locks. The cycle repeats. 400 to 600 times per minute. Simple enough that teenage Marines mastered it after minimal training. Robust enough to fire thousands of rounds without failure. This was democracy-made steel. The weapon of a nation that understood modern warfare's essential equation. Overwhelming force, applied continuously, delivered by systems so reliable they became mechanical extensions of human will. The transformation happened with shocking speed. December 7, 1941, Pearl Harbor burns. By January 12, 1942, General Motors' Saginaw Steering Gear Division begins retooling. Assembly lines that had produced automotive components now produced instruments of war.
The workers were the same. The techniques were the same. The philosophy was identical. Mass production, interchangeable parts, division of labor, quality through consistency rather than individual craftsmanship. Watch how it worked. A worker who had spent years installing steering columns in Buicks now installed barrels in Brownings. The muscle memory translated. The precision required was similar. The speed achievable was identical. That worker could complete their specific operation in seconds, pass the weapon down the line, and begin the next one. Multiply that worker by thousands. Multiply those operations by hundreds per day. By 1943, Saginaw alone produced 10,000 M1919s monthly. More machine guns in a single month than Japan would manufacture in an entire year. Buffalo Arms Corporation joined the effort. Rock Island Arsenal ramped up production. Dozens of subcontractors supplied parts. The beauty of the system was its redundancy. If one factory suffered a setback, others compensated. If one supplier couldn't deliver, alternatives existed. And the parts were truly interchangeable. A barrel machined in Buffalo would fit a receiver from Saginaw. A bolt made at Rock Island would function in either. This wasn't just convenient, it was revolutionary. Field armorers could cannibalize damaged weapons to repair others. Supply chains simplified. Maintenance became straightforward. The quality control was ruthless in its statistical precision. Random sampling, rigid specifications, test firing. Any weapon that failed inspection was either repaired immediately or stripped for parts. The rejection rate was minimal because the manufacturing process itself ensured consistency. By the time the war ended, American factories had produced nearly 390,000 M1919 machine guns across all variants. Think about that number, 390,000. In 4 years of war production, that's 270 machine guns completed every single day for 1,400 consecutive days. The ammunition production made the gun numbers look conservative. Over 10 billion rounds of .30-06 annually by 1944. Enough ammunition to sustain continuous fire from every M1919 in service simultaneously for months. Moisture-proof containers protected the rounds during Pacific shipments. Standardization meant that whether manufactured in Denver, St. Louis, or Salt Lake City, every cartridge would function perfectly. The logistics were almost boring in their efficiency. Order ammunition, receive ammunition, load ammunition, fire ammunition, request more.
Innovation continued throughout production. Armor-piercing M2 rounds for bunkers and light armor. Tracer ammunition in multiple varieties. Standard red tracers for target marking. Dim tracers for concealed positions. Delayed tracers that didn't ignite until 100 yards out to avoid revealing the shooter's position. Incendiary rounds. Armor-piercing incendiary combinations. The M1919A6 variant arrived in late 1943, adding a shoulder stock, carrying handle, and bipod. 32 pounds without the tripod. Heavier than ideal for a light machine gun, but offering flexibility for small unit operations. Marines developed field modifications that entered official production. The Basilone Bale, a wire and wood handle for safely moving hot barrels, was invented by Medal of Honor recipient John Basilone based on his Guadalcanal experience. What worked in combat influenced what got manufactured. The feedback loop was continuous. This was America's secret weapon. Not the M1919 specifically, but the system that could produce 390,000 of them, while simultaneously building tanks, aircraft, ships, and every other implement of modern war. The industrial capacity that made overwhelming force inevitable. 8,000 miles across the Pacific, a very different philosophy governed weapons production. The Japanese Type 92 heavy machine gun represented everything that traditional military craftsmanship aspired to be. Precision machined parts, careful hand fitting, attention to detail that bordered on artistic. It was also exactly wrong for industrial warfare. The Type 92 emerged from France, ironically. Japan had licensed the Hotchkiss machine gun design in 1905, using it through the Russo-Japanese War and beyond. The Type 92, adopted in 1932, the 2592nd year of the Japanese imperial calendar, was meant to modernize this proven design. On paper, it looked formidable. Gas-operated rather than recoil-operated. Firing the 7.7 by 58 mm semi-rimmed cartridge, a more powerful round than Japan's earlier 6.5 mm rifles used. Air-cooled for mobility. Capable of 450 rounds per minute. The weapon seemed to match contemporary standards. Reality was more complicated. The Type 92 weighed 122 pounds complete with its tripod. 77 pounds heavier than the M1919 system weight. This wasn't just inconvenient, it was tactically catastrophic. A weapon that heavy couldn't be rapidly repositioned. Once emplaced, the Type 92 crew was committed. Move meant abandoning the gun or spending critical minutes disassembling and carrying component parts. The weight came from over-engineering. Japan's manufacturing philosophy valued precision fitting and robust construction. Components were machined to tight tolerances and hand-fitted by skilled workers. Each weapon was essentially custom-built. The result was mechanically impressive and tactically disastrous.
But the Type 92's fatal flaw was more fundamental: the ammunition feed system. 30-round metallic strips, not belts, strips, rigid, fragile, easily bent or damaged. Each strip took precious seconds to load, during which the gun could not fire. In combat, those seconds meant death. American 1919 gunners could link cloth belts together indefinitely, 500, 750, even 1,000-round configurations. Continuous fire limited only by barrel heat. Type 92 crews faced mathematical impossibility. Fire 30 rounds at 450 rounds per minute. That's 4 seconds of firing. Then stop, reload. Another strip. 4 more seconds. Stop, reload. An M1919 firing 600 rounds per minute from a 250-round build could sustain fire for 25 seconds without reloading, 6 times longer than the Type 92 could maintain continuous fire. The strips themselves were precision items requiring careful manufacturing. Humidity could rust them, rough handling vent them. Combat conditions destroyed them. Each was a separate failure point. Drop a box of Type 92 strips and you might render half your ammunition unusable. And then there was the oiling system. The Type 92 incorporated an internal oil pump that automatically lubricated cartridges as they fed into the chamber. This solved a mechanical problem with the Hotchkiss action that required primary extraction assistance. In theory, it ensured smooth operation. In the Pacific Theater, it ensured mechanical failure. Think about what happens when you pump oil into a mechanism operating in jungle humidity. The oil attracts moisture. Moisture attracts dirt. Dirt mixes with oil to create an abrasive paste. That paste attracts more dirt, more plant matter, more coral dust. The precisely fitted parts that worked beautifully in peacetime demonstrations seized solid in combat conditions. On coral atolls like Tarawa and Pilaliu, fine sand combined with oil to create grinding compound. The Type 92's tight tolerances meant even small amounts of debris caused malfunctions. The oil pump that was supposed to enhance reliability became the primary cause of failure. The weapon's complexity compounded every problem. Adjusting the oil pump for temperature and humidity required expertise. The offset sights complicated training. The gas operation system needed constant tuning. Feed strip alignment was critical. Every aspect of the Type 92 demanded attention that combat rarely afforded. Tokyo Gas and Electric Company received the primary Type 92 manufacturing contract. Hino Motors and Hitachi contributed production. These were respectable companies with experience in precision manufacturing. They produced industrial equipment, electrical systems, automotive components. They were not prepared to produce 390,000 of anything. Japanese manufacturing philosophy emphasized quality through craftsmanship. Skilled workers carefully fitted components. Master armorers inspected each weapon. The process was methodical, thorough, and glacially slow by American standards. Early Type 92s featured beautiful rust blue finishes, precisely fitted parts, careful attention to detail. They were works of craftsmanship that would have impressed in any peacetime arsenal. They were also produced at rates measured in hundreds per month, not thousands. From 1932 to 1945, 13 years of production, Japan manufactured approximately 45,000 Type 92 heavy machine guns, total, for the entire war and the decade preceding it. That's 288 weapons per month averaged over the production run. In practice, wartime production peaked higher but never approached American rates. By 1943, Saginaw alone, one American factory, was producing 10,000 M1919s monthly, 35 times Japan's average monthly Type 92 output. One factory, 1 month. More machine guns than Japan made in a year. The mathematical reality was crushing. 390,000 American machine guns versus 45,000 Japanese, an 8.7 to 1 advantage. But that ratio understates the actual disparity, because many of those 45,000 Type 92s were obsolete earlier models, and production quality declined catastrophically as the war progressed. By 1944, material shortages forced compromises. Cast iron replaced steel in non-critical components. Wooden handles appeared where steel had been standard. Simplified sights, rough machining marks. The meticulous precision of early production gave way to desperate expediency. Late-war Type 92s were mechanically degraded from the beginning. The oil pump system, already problematic, became completely unreliable with inferior metallurgy and declining manufacturing precision. Pumps delivered too much oil, drowning the action, or too little, causing extraction failures. American intelligence reports from captured weapons noted that late-war Type 92s required complete rebuilding before they could be test-fired. Even Japanese military inspections rejected increasing percentages of new production. But desperation meant substandard weapons shipped to combat units anyway.
The inability to innovate or adapt compounded the production failures. The Type 92 that fought at Guadalcanal in 1942 was essentially identical to those manufactured in 1945. No improvements addressed the oiling system problems. No redesign eliminated the feed strip limitations. No reduction in weight made the weapon more mobile. Japanese industry simply couldn't accommodate changes. Retooling required resources that didn't exist. Modification meant reducing already inadequate production. The Type 92 was frozen in its flawed configuration by industrial limitations as much as military conservatism. Henderson Field, Guadalcanal, the night of October 24, 1942. The Japanese Sendai Division attacks in waves against Marine positions, reinforced by M1919 machine guns positioned for interlocking fields of fire. This is where theoretical advantages become measured in bodies. Marine machine gun crews open fire at ranges exceeding 600 yards. The M1919's .30-06 rounds reach out with lethal authority. Tracers paint red lines through the darkness. The guns settle into their rhythm. Bursts of fire, barrel changes, more bursts, sustained, mechanical, industrial. Japanese Type 92s return fire with their distinctive talk cadence. 30 rounds, pause, reload. 30 rounds, pause. The pauses are where Marines advance, where fire teams move forward while the Woodpeckers are silent. Private First Class Mitchell Page, who had earned the Medal of Honor this night, described the tactical reality. The air-cooled 30s were our mobile reserve. When the Japs broke through, we could grab the gun and tripod and run to plug the gap. Try that with a Type 92. The weight difference, 45 pounds versus 122 pounds, represented the gap between fluid defense and fixed positions. American guns moved. Japanese guns stayed. In combat, staying in one place meant dying as soon as American artillery or mortars plotted your position. The reliability differential was even critical. M1919 soaked with seawater during amphibious landings continued functioning after basic cleaning. Type 92s exposed to salt water required extensive maintenance just to attempt firing. Often they couldn't be salvaged. Tarawa, November 1943. Corporal James Russell of the 2nd Marine Division advanced his M1919A4 across the coral-strewn battlefield by hand. He testified later, "The gun never quit. We dump water from our canteens on the barrel to cool it, wipe the sand off the belt, and keep firing. We burned through 10 boxes of ammo, 2,500 rounds, and never had a stoppage." Meanwhile, Japanese Type 92s defending Betio Island suffered constant malfunctions from coral dust mixing with the oiling system. The precisely fitted components that had seemed so impressive in peacetime testing seized solid. Gunners desperately tried to clear jams while Marines advanced on their positions. Saipan, July 1944. The massive bonsai charge of July 7th provided the most dramatic demonstration of firepower disparity. When 4,000 Japanese soldiers attacked American positions, M1919 crews of the 27th Infantry Division created interlocking fields of fire that transformed human assault into systematic slaughter. Sergeant Thomas Baker's M1919 crew fired continuously for 6 hours. Assistant Gunner Carl Morrison recalled, "We had spare barrels ready. When one got too hot, we'd swap it out in 10 seconds and keep shooting. The Japs just kept coming and we just kept killing them. Our gun alone must have dropped a couple of hundred of them." The mathematics were pitiless. An M1919 firing 500 rounds per minute for 6 hours, even with barrel changes and reloading pauses, could reasonably fire 100,000 rounds. That's 333 standard 250-round belts. 2 men with enough ammunition and spare barrels could maintain fire that no infantry force could cross. A Type 92 crew attempting the same? They'd need to load and fire 3,333 30-round strips. At 4 seconds per strip plus reload time, that's over 4 hours just feeding ammunition. The weapon would overheat and fail long before completing the task. Peleliu, September 1944. The 115-degree heat provided the ultimate test of mechanical reliability. Type 92s seized from thermal expansion of their precisely fitted parts. The tight tolerances that were supposed to ensure accuracy became death sentences as mechanisms literally welded themselves solid. M1919s continued functioning. Corporal Sterling Mace observed, "The Woodpeckers would fire a strip or two, then go silent, jammed again. Our 30s just kept hammering away. We knew we had fire superiority, and that gave us the confidence to keep advancing." Captured Japanese documents revealed growing awareness of their firepower disadvantage. A diary recovered from an officer on Saipan noted, "The enemy's machine guns fire continuously without pause. Our Type 92s must stop to reload every 30 rounds, while the Americans seem to have endless ammunition. We cannot advance through their fire. One American gun does the work of 5 of ours. Another report from Guadalcanal stated, "Enemy automatic weapons create a solid wall of bullets. Our Woodpecker cannot compete with their sustained fire. They have removed the human element from killing. It is pure machinery." That phrase, pure machinery, captured the essential horror. American firepower had industrialized death. The M1919 didn't rely on individual marksmanship or warrior spirit. It relied on mechanical reliability and overwhelming ammunition supply. Pull trigger, gun fires, feed belt, gun fires, change barrel, gun fires. The psychological impact was crushing. Japanese soldiers began calling American positions the lawnmower for the way M1919 fire cut down attacking waves with mechanical efficiency. The continuous chatter of American machine guns became a sound that demoralized Japanese forces before attacks even began. Lieutenant Hiroaki Semishima, captured on Luzon, provided detailed testimony. "We knew our machine gun was inferior. The oil pump constantly failed. In jungle humidity, the oil became like glue mixing with plant matter and dirt. We spent more time cleaning than firing. The strips bent easily, and each held only 30 rounds. By the time we reloaded, the Americans had killed half our squad. We called their machine guns Hitler's zipper because of the sound, like a zipper opening, but much more terrible." Japanese military analysis found at Kure Naval Base after the war admitted defeat. The Type 92 heavy machine gun has proven inadequate against American forces. Their M1919 series weapons achieve fire superiority in every engagement. Recommendations for improvement cannot be implemented due to production limitations. Units must rely on courage to overcome mechanical disadvantage. Read that last sentence again. Units must rely on courage to overcome mechanical disadvantage. This was an admission that the war had been lost in the factories, that no amount of warrior spirit could compensate for industrial inadequacy, that courage, however magnificent, couldn't make 30-round strips reload faster, or make 122-pound weapons lighter, or make precisely fitted parts work in tropical conditions. The banzai charges that characterized late-war Japanese tactics emerged partly from this recognition. If you can't win firefights against superior American firepower, the only option is to close to hand-to-hand range, where firepower advantages are negated. It was tactical desperation born from industrial failure. Those charges resulted in staggering casualties. Not because Japanese soldiers lacked courage, they had courage in abundance, but because courage can't defeat mathematics. Attacking across open ground against M1919 positions meant entering kill zones where sustained fire made survival impossible. April to June 1945, the last great battle of the Pacific War. By this point, American forces had refined their machine gun tactics through 3 years of combat. M1919 crews worked in perfect coordination, creating interlocking fields of fire that made Japanese attacks suicidal. During the massive Japanese counteroffensive of May 4, 1945, American machine guns faced human wave attacks of unprecedented intensity. M1919 crews from the 96th Infantry Division fired without pause for over 12 hours. Staff Sergeant Beaufort Anderson's machine gun section expended 30,000 rounds in a single night. 6 spare barrels worn out from sustained fire, not one stoppage. "We just kept feeding belts and changing barrels," Anderson recalled. "The gun never quit. Bodies piled up in front of our position until they blocked our field of fire, and we had to shoot through them." 30,000 rounds from one machine gun position in one night. Try to visualize that. 30,000 individual .30-06 cartridges cycled through one weapon, each round loaded, fired, extracted, and ejected, each representing a manufacturing process that began in American factories, passed through supply chains spanning the Pacific, and ended in Okinawa's mud. The logistics supporting that single night's firing were staggering. 30,000 rounds weighed approximately 1,500 pounds. That's 120 boxes of ammunition that had to be manufactured, shipped across the Pacific, transported to the forward position, and fed into the gun. The supply chain required to sustain one machine gun position for one night. Now multiply that by thousands of M1919s firing simultaneously across Okinawa's entire front. Japanese Type 92 machine gun crews at Okinawa fought with incredible bravery, but were hamstrung by their weapons' limitations. The inability to sustain fire meant American forces could advance between reloading cycles. When Type 92s did score hits, the psychological effect was minimal compared to the overwhelming streams of fire from M1919s that could sweep entire areas clear of life in seconds. The cave warfare that characterized much of Okinawa's fighting highlighted another critical advantage. The M1919's portability meant Marine and Army units could bring machine guns deep into cave complexes, providing firepower in confined spaces. The 122-pound Type 92 was essentially immobile in such conditions. American after-action reports noted that captured Type 92s were often found abandoned in caves, their crews unable to displace them when positions were overrun. Many were discovered with jammed mechanisms, broken feed strips scattered around the position, testament to their crews' desperate final moments. One telling statistic: American forces captured more than 200 Type 92 machine guns on Okinawa. Only 12 were in working condition. The rest had been abandoned due to malfunctions, destroyed by their crews to prevent capture, or were so worn out as to be irreparable.
In contrast, American M1919s that had been in continuous combat since Guadalcanal, 3 years of hard use, were still functioning reliably. Step back from the tactical details. Look at the bigger picture. The Pacific War was fundamentally a contest between industrial philosophies. America's approach: standardization, mass production, interchangeable parts, weapons designed for manufacture by automobile companies using workers who'd been building cars months earlier. Good enough quality in overwhelming quantities. The M1919 embodied this philosophy. It wasn't the most accurate machine gun ever designed. It wasn't the lightest. It wasn't the fastest firing. It was adequate in every category and overwhelmingly reliable. A weapon that could be produced by the hundreds of thousands, maintained by teenagers with minimal training, and employed in any condition. Most critically, it was designed for production. The loose tolerances that some criticized were deliberate engineering choices that facilitated mass manufacture. Parts didn't need hand fitting. Workers didn't need years of training. Assembly lines could stamp out weapons with automotive efficiency. Japan's approach: precision, craftsmanship, individual attention to each weapon. Manufacturing techniques inherited from centuries of sword-making tradition where master craftsmen produced small numbers of superior weapons. The Type 92 embodied this philosophy. Precisely fitted parts, meticulous attention to detail, complex mechanisms that required skilled assembly and adjustment. In peacetime, these were virtues. In industrial warfare, they were fatal flaws. The comparison reveals everything. By 1944, American factories were producing more M1919s in a single month than Japan produced Type 92s in an entire year. This wasn't just about industrial capacity, though America's was vastly superior. It was about fundamentally different understandings of modern warfare's requirements. American planners understood that modern war was attrition, that the side which could replace losses faster and sustain greater consumption rates would win, that reliability and quantity mattered more than individual weapon quality, that the goal wasn't to produce the perfect machine gun, it was to produce enough machine guns to equip every unit with overwhelming firepower. Japanese planners, trained in traditions valuing individual warrior quality over mass, never fully grasped this shift. They produced precision weapons as the warfare was still decided by skilled individuals with superior equipment. They couldn't comprehend an enemy who would deliberately design loose tolerance weapons because reliability mattered more than theoretical precision.
The oil pump system perfectly illustrated this disconnect. Japanese engineers solved a mechanical problem, the Hotchkiss action's extraction weakness, with mechanical complexity. They added a component that theoretically ensured reliability. They tested it in controlled conditions where it worked perfectly. They never considered that adding complexity is the enemy of reliability in combat conditions, that the oil attracting dirt was worse than occasionally failed extraction, that soldiers under fire couldn't maintain complex mechanisms. American engineers understood this instinctively. They designed for the worst possible conditions and accepted reduced maximum performance in exchange for consistent minimum performance. By war's end, the production disparity had decided everything. 390,000 M1919s versus 45,000 Type 92s. But the real advantage was multiplicative. Those 390,000 American machine guns were supported by over 10 billion rounds of standardized .30-06 ammunition annually. Completely interchangeable parts across all manufacturers. Simplified maintenance requiring minimal training. Robust performance in any environmental conditions, and sustainable production that could replace losses immediately. Those 45,000 Japanese machine guns struggled with limited ammunition production of non-standardized 7.7mm rounds, parts requiring individual fitting from specific manufacturers, complex maintenance demanding expertise rarely available in combat, degraded performance in tropical conditions, and declining production quality as war progressed. The American advantage compounded at every level. More guns meant more firepower. More ammunition meant sustained fire. More reliability meant guns stayed in action. More production meant losses didn't matter. More standardization meant logistics simplified. For Japan, every advantage became a disadvantage. Fewer guns meant concentrated firepower positions. Limited ammunition meant conserving fire. Less reliability meant guns out of action. Limited production meant losses were irreplaceable. Complexity meant logistics nightmares.
By 1945, the disparity had reached almost comical proportions. American forces had so many M1919s that multiple weapons were assigned to positions that might have had one gun the previous year. Ammunition was expended with abandon because supply was unlimited. Weapons were sometimes abandoned rather than recovered because replacements were readily available. Japanese forces husbanded their Type 92s like treasures because they were irreplaceable. Ammunition was carefully rationed. Every round counted because resupply was impossible. Crews maintained their weapons with almost religious devotion because failure meant the position lost its only heavy firepower. The M1919 Browning continued service long after World War II ended. Korea, Vietnam, numerous other conflicts. Many Allied nations used the weapon into the 1990s. Some M1919s converted to 7.62mm NATO are still in service today. Weapons manufactured in the 1940s still firing in the 2020s. That's 80 years of service, from a weapon designed in 1919 and perfected by 1936. The M60 machine gun that officially replaced it incorporated many M1919 design elements. The M240 that replaced the M60 traces lineage back to Browning's original concepts. The Type 92, despite its limitations, earned grudging respect from American forces for the bravery of its crews. Captured weapons became prized souvenirs. Veterans would demonstrate them at stateside bond rallies, showing amazed audiences the awkward feed strips and complex mechanism while emphasizing American technical superiority. Ironically, many Type 92s brought home as trophies survive in better condition today than they ever achieved in combat. Collectors lovingly maintain them with the constant attention these weapons require. In museum displays and private collections, the Type 92s gleam with careful preservation, finally receiving the peacetime care they always demanded but rarely received. Post-war testing at Aberdeen Proving Ground confirmed what Pacific veterans already knew. Even under ideal conditions with perfect maintenance, the Type 92 could not match the M1919's sustained rate of fire. The oil pump system was fundamentally unsuited for military use. The feed strips were obsolete technology. The excessive weight made the weapon tactically inflexible.
The official report concluded the Type 92 is a peacetime weapon unsuited for modern warfare. Stand in Betio Island today. The concrete bunkers still stand, concrete harder than the coral beneath it. Shell craters have softened with 70 years of erosion. The beaches are peaceful. Walk the ground where Corporal Dean's M1919 cut down Japanese charges in November 1943. The coral doesn't remember the blood. The palm trees weren't witnesses, but the battlefield's geometry remains unchanged. From this position, Dean's gun could cover 180 degrees of approach. The beaten zone, the area where bullets fell, extended hundreds of yards. Any human being entering that zone had a life expectancy measured in seconds, not because Dean was a particularly good shot, because the M1919 delivered mechanical, consistent, overwhelming firepower that no human could evade. Now imagine that same position defended by a Type 92. The 122-pound weight means the gun cannot be repositioned once in place. The 30-round strips mean firing stops every 4 seconds for reloading. The oil pump means the tropical humidity will cause malfunctions. The tight tolerances mean coral dust will jam the mechanism. That's the difference. That's the war in microcosm. The M1919 versus Type 92 comparison reveals a truth about the Pacific War that extends far beyond machine guns. It exposes how fundamentally different industrial philosophies determined the war's outcome before the first shot was fired. When General Motors' Saginaw division began producing M1919s in early 1942, the war was already decided. When American factories geared up to mass-produce standardized ammunition by the billions, the outcome became inevitable. When the philosophy of good enough in overwhelming quantities met the philosophy of precision craftsmanship in limited numbers, the result was predetermined. Courage was equal on both sides. Japanese soldiers demonstrated bravery that American Marines and soldiers respected and feared. But courage cannot overcome mathematics. Warrior spirit cannot make 30-round strips reload faster. No amount of training makes 122-pound weapons more mobile. The Pacific War was won by assembly lines, by workers in Detroit and Buffalo and Rock Island who applied automotive manufacturing techniques to weapons production, by a nation that understood modern warfare was industrial rather than martial, by the recognition that overwhelming adequate force beats limited superior force. John Moses Browning died in 1926, never knowing his weapon would help win the Pacific War. But his design philosophy, simple, reliable, manufacturable, proved more powerful than any individual weapon system. The M1919 wasn't successful because it was the best machine gun ever designed. It was successful because it was good enough to win, and America could produce 390,000 of them.
Japan's Type 92, for all its precision engineering and careful craftsmanship, represented a dead end, an approach to warfare that belonged to an earlier era. The philosophy that produced it, valuing individual weapon quality over mass production, couldn't compete with industrial warfare's demands. The woodpecker versus the zipper, the artisan versus the factory, precision versus quantity. In every comparison, the winner was predetermined by decisions made in factories years before battles were fought. When dawn broke over Betio Island on November 21, 1943, and Corporal Dean's M1919 began its terrible work, the outcome was never in doubt. The battle had been decided in Detroit. The war had been won on assembly lines. The Pacific Campaign was simply the process of confirming what American industrial power had already determined. The M1919 Browning stands as testament to a nation that understood the 20th century's essential lesson. Modern war is industrial. The side with more factories, better logistics, and superior production capacity wins. Not eventually, not theoretically, inevitably. 390,000 M1919s versus 45,000 Type 92s. The numbers tell the entire story. The factory war decided the Pacific War. Everything else was just details.